In this session, our speaker will walk through some examples of code generated by ChatGPT, and show that while AI can boost developer productivity, we still need to rely on our good old-fashioned gray cells and hard-earned experience to ensure sustainability and quality of our applications and systems. He has been a software developer for over 3 decades and is currently an executive director with JP Morgan Chase Global Technologies, where he is helping to build up a dojo capability. Please welcome Mr. Junilu Lakar.
Oh, okay. Got clicky there. Hey, everybody. I am calling in from Ohio in the U.S., and I'm very excited to be here again. I don't know, this is like my third or fourth time presenting in this conference, and I'm very thankful for to the organizers for giving me this opportunity again. I'm going to start my presentation so we can get right down to brass tacks. Um, Oops. Back up. Back up. Too much. There you go. Can everybody see the presentation? Let me go to the first part and start this slideshow from beginning. All right. So I changed the title a little bit to "Are You Smarter Than an AI?" And one request I want to make before I go to the meat of this is I'd like this to be more interactive. I don't want to be talking the whole time and just me, because one of the things I do as a dojo coach is try to make the learning um, a little bit less one-sided. I mean, I like it to be a conversation and an exchange of an ideas. So my request is that when you guys see this icon over here, the crowd icon, that you participate and share your experiences, opinions, ideas, and if you have anything that sticks out in your mind that you're going to be taking away from this session, share it with everybody else in the chat. Okay. And also, one thing I'd like to do is because I'm not going to be doing this presentation the whole time. Um, Part of it is, hopefully, most of it is going to be an exercise going through some code that ChatGPT has generated, and it's a very simple problem, really. It's kind of almost like a classroom type problem. Essentially, it's tic tac toe. I asked ChatGPT to write a Java program that will play tic tac toe with a human against a computer, and you'll see what it gave me. I asked for a couple of versions actually, but I'd like to go through an exercise where we're actually or we're pitting our skills against what ChatGPT is able to do at this point. And I just want to give this disclaimer that I am by no means an expert in this technology. I have very minimal experience with generative AI, and I am not an expert in this field yet. I do plan to start boning up on it. Um, but what I do have, and apologies to Liam Neeson, are a very particular set of skills that I have acquired through a very long career. I've been in this business for over 30 years now, and I pretty much can smell anything that's wrong in code. And if there's anything that's bad with code, I will find it and I will refactor it. I know this is kind of cheesy. Again, that's why the apologies. Um, but the one expert that I do rely on a lot is this guy, Kent Beck. And hopefully you all know who Kent Beck is. If not, then look him up, please, because he's a very important person in our industry. He's one of the fathers of extreme programming, and he's the one of the pioneers in the practice of test-driven development, simple design, and all this stuff. And great timing. Last night was when I first, I think it was released just last night, and I happened to see a post on LinkedIn from Woody Zool, who is the mob programming guy, and he said, Kent Beck's book has dropped on Amazon, and this book, I've been waiting for this book for a while, and luckily enough, my company gives us access to O'Reilly online, and I started reading through this. There's a lot of things that I'll probably lean on um, from this book, or maybe touch on a little bit, that are relevant to the discussion tonight or today. So if you have a chance, go get this book because I think it's full of really great advice for developers. Um, so this tidy first thing, what is tidy first? Tidying is a subset of refactoring, and Kent describes it in his book as these are cute, fuzzy little refactorings that nobody could possibly aid on. So why should we tidy up? And believe me, be patient a little bit. I know that this is the first time I'm doing this presentation, so it may be a little bit incoherent and a little bit disjointed. But believe me, I'm getting to a point. So refactoring and AI are going to come together in a bit. So why should we tidy up code? And again, this icon means that this is where I'm going to turn to you guys and see if you have any ideas you want to share. Why should we be tidying up code? Let me check the chat and see if you guys have any opinions. Reducing clutter, reducing technical debt. Great. Cleaner, clean code, easy to maintain, others can understand, readability. Awesome. These are great answers. Um, and I was hoping that some of you would actually give those answers, which is great because you did. And if you want to speak up later on, too, please just raise your hand. I think there's a way to indicate that you want to talk, and our moderator will give you the mic if you do want to come on stage and speak up, have your voice heard. So those are really great thoughts that you have. But there was one thing there that kind of resonated with me too, because I used to think that, yeah, as an engineer, it's my responsibility to write clean code. But then I heard what Martin Fowler said about this kind of attitude. This quote. I think the most dangerous way people get trapped is when they try to justify refactoring in terms of clean code or good engineering practice or similar moral lessons. Like moral lessons, like something that one of my kind of mentors, idols, people that I look up to in the industry, Uncle Bob, or Bob Martin. Um, he used to talk about professionalism, and if you didn't do TDD, then you're not really behaving like a professional. So this is the kind of moral based stance that Martin Fowler is talking about. So what is then? Why is it dangerous to talk about refactoring in this way? And what's his opinion? What's the best way to talk about refactoring? Um, so he says refactoring is really about economics. It's important to keep that in front of your mind and when you're communicating with others, because the economic benefits of refactoring should be the driving factor. That's the why of refactoring and tidying up. And I'll go into some details of, what the economics are. And because if we do keep that in mind, then this is really where we're going to be seeing that good design curve um, coming out of the conversation. So, and this is another gem I just found this afternoon from the Tidy Up, Tidy First book. Kent Beck in his book, I think it's chapter 6, says the biggest cost of code is the cost of reading and understanding it, not the cost of writing it. Right? And this really resonates with me because there's another statistic that says that code spends most of its lifetime being read. You write it maybe 30% of the time it's being changed or written initially, and then afterwards it's being modified. But most of the time, code is being read. I think like 70% of the time it's being read by others. So it's really important that we have that readability quality and understandability, right? And I'm glad that some of you, there was a mention of these qualities, that if it's hard to understand, if it's hard to read, then we should really start tidying up the code. So when should we tidy up? And you can interpret this question however you want. And I'd like to see again what your thoughts are. When do you tidy up? And Kent Beck mentions a few things about when in his new book too. So let's see what you guys are saying. It's for your future self, code readability, fast load times, readability. Um, all right. I think this is still why. When? When is the question? We should tidy up when? When always. That's a good answer. As we go along, clean as you code. I'm really encouraged by all these answers. I'm glad because it indicates to me that a lot of these ideas are starting to spread. And in previous years and in my experience as a coach, not many developers share these thoughts, right? During unit testing, clean always and create new bugs. Cool. All right. Thank you. Let me get back to this. When should we be tidying up? So those answers are actually really good, and I think they agree with what Kent Beck said. Somewhere in the middle of, I think he said, somewhere in the middle of, I forgot what he said. There's a balance anyway that he strikes in. It's not. I think it's about refactoring so that you can keep creating features easily, right? And there's a point where some people will stop creating features or writing valuable code and just say, this code is such a mess. We have to spend a lot of time cleaning it up. Now, that's one extreme. And the other extreme is like it's just refactoring for the sake of refactoring, right? It's like even though the code is already good enough, you still want to. It's kind of being a perfectionist. Is I don't want people to say bad things about me as a coder, so I want to make sure that it's really, really, really clean. So those are two extremes where it's wait until it's a really big mess, or not tolerate any kind of mess at all and just keep cleaning. It's kind of like I have a friend who used to be in the Navy, and we went to visit his house one time, and uh, it almost seemed like he was being obsessive. He was sweeping the floor, and he just walked through, and he's sweeping the floor again. So it's funny that some of his habits from the Navy carried over to his civilian life, where he couldn't stand any kind of disorder or dirtiness in his house. So if he saw something that was out of order, he had to go and clean it up right away. So that's the other extreme, right? And then there's people like me who are big slobs, and if you could see just the mess that I have in this room right now, then you'd be like, oh my god, how can you be talking about clean code and have your room like this? But anyway, that's neither here nor there. So Kent Beck's thing is we should be cleaning somewhere in the middle where we it's just enough to allow us to keep going at a sustainable pace, and don't obsess too much about perfect code because you're never going to have perfect code. Hopefully, I'm doing justice to what he wrote and what I read. You guys mentioned, I think, technical debt. So here's another question I have for you. What in your mind is technical debt? What exactly constitutes technical debt, and how do you recognize it? Refactor now, merge conflict later. Okay. Personally, once I get the code working, then I do cleanup. I can do optimizations. Okay. Code smells. Those are tech. Okay. Capability building. Bad code. All right. These are interesting answers. Code smells. Bad code. Putting off problems for your future self to solve. It happens when you take shortcuts. Put in a mode. Okay. Tech debt. Something that we could have. All right. So no unit test. Okay. And yes, those are all things that a lot of people associate with the term technical debt. But do any of you know where the term came from, or who originated that term, technical debt? Nope. Anybody? I'll give it a couple of seconds more. Who? Where did that term come from? Technical debt, and it's an old. No, it's not Uncle Bob. Although Uncle Bob talks about technical debt a lot. So technical debt actually originated as the debt metaphor. And the debt metaphor was coined by this guy, Ward Cunningham. I don't know if you guys are familiar with Ward. He's one of the I want to say less popular of the 17 original Agile Manifesto signers. But he was the inventor of the wiki. He he's actually the father or grandfather of extreme programming, and he coined the debt metaphor. Back in the 90s, I think in the mid 90s, he was working on this project on this software, and it was financial software. It's called Ycash, and this is how he explains it. And if you look for Ward Cunningham explains the debt metaphor on YouTube, you'll find a 4 minute video or 4 to 5 minute video where he goes through all this. And this is where I took these quotes from. He coined the debt metaphor to explain to his managers at the time the things that they were doing to modify the program to look as if they knew what they were doing in the first place, right? And that it was easy to do. And he goes on to say, because if we fail to make the program align with what we then understood to be the proper way to think about our financial objects, because this was a financial software. The reason I cross this out is make it more general. He's really talking about the design, right? A proper way to think about our design, our solution, our code. Then, if we don't make our program align to that way, the way we're thinking about these ideas, then we're going to stumble over that disagreement, and that would slow us down. And getting slowed down by this disagreement was like paying interest on a loan. So this is where this whole financial metaphor came from, because he was working with a financial software. He thought that a financial analogy would be more resonant with the managers that he was working with. So that's why it was about debt. So in that video again, he says, if you develop a program for a long period of time by only adding features and never reorganizing it to reflect your understanding of those features, then eventually that program simply does not contain any understanding, and all efforts to work on it take longer and longer. I think to a lot of developers, this should resonate with you, because this is really what resonated with me. And when I watched this video, I was like, yeah, that's absolutely right. I mean, when we have such a mess that all we do is spend time looking at the code and trying to understand what the heck it's saying, then that's really the biggest cost of the software, right? It takes us, and the worse it gets, the longer it takes to even do anything, like a simple thing. So I want to dig into this metaphor a little bit. Seeing I'm already 20 minutes in, I want to get through this as quickly as possible. But this part I want to point out is, you know, borrowing money, with the financial analogy, Ward explains that, you know, debt isn't a bad thing. It could be a good thing, because when you go into debt, you borrow money, for example, you can buy things or you can do things that you couldn't otherwise. But there's an understanding that you have to pay back that debt, right? You go into debt, you have to pay it back, and then there's a little bit of penalty and interest. But if you go into arrears and you start kind of not owning up to the responsibility of paying back the loan, then you start getting penalties and all this stuff, and it starts to accrue. And that's where you get in trouble. So by the same token, rushing software out the door is actually a good thing, in Ward's mind, because there's only things that you can learn about the software by running it. You you know, those things, like, I can code it so much, but if I run it, then I'll learn a lot quicker. I'll get feedback about what's happening, and I'll that feedback will allow me to adjust my understanding of what the heck I'm writing here, and what the effect is on the program and the overall behavior of it. And so by rushing software out the door, and not trying to get it to perfect yet, by getting that experience with it, then you gain some understanding, and then you pay that back by refactoring. But the refactoring, for me, I'm trying to map these ideas to each other. The principle is what the refactoring is, but what's the interest part? So a lot of people think that it's quality, right? I have to put back quality because I rushed the software out the door. There was a lack of quality in it. And by refactoring, I'll pay back that quality. Now, that's not what Ward actually had in mind, though. So he goes on again in that video and says, a lot of bloggers and presenters have taken this idea of technical debt and confused it with the idea that you could write code poorly with the intention of doing a good job later, and thinking that that was a primary source of debt, that quality is what you're lacking, and it's that bad code that constitutes technical debt. But he says, I'm never in favor of writing code poorly, but I am in favor of writing code to reflect your current understanding of a problem, even if that understanding is partial. So this is crucial. The word understanding, right? This is key here, and I think this has helped formed my stance and opinion about software, about how to make how to write good software, how to write good programs, and what's good enough, right? That understanding thing. Again, go back to the Kent Beck quote. It's most of the time you're reading code. The biggest cost is reading, understanding, and maintaining it, right? So really, I think the 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 part that maps the interest is you're paying back the yung patong, in Tagalog or Bisaya, the the vig, right? Or the interest is really that understanding that you're putting back into the software, into the program that you've written. And if you don't do that, then you're going to get some penalties, right? If you don't put back understanding, once you gain experience and get a better understanding of what's going on in your code, if you don't put that back and make your code reflect it, then that's where you're going to incur a lot of costs. Um, but lately, I mean, with that mapping, I came to the conclusion that really technical debt is anything that slows us down and makes it harder to understand and work with the code. But for reasons like, there's still a gap here in the mapping to me. So I've recently read something in one of the books I've been reading on Amazon Prime. Um, this I forget what book it is, but somebody talked about friction. So I've tried using the word friction in this statement, and it works for me because really friction is anything that causes chaos, causes um, confusion, right? And so I think from now on, what I'm gonna do is talk about friction instead of technical debt because technical debt is highly subjective now, and I think friction is actually a better word to describe the phenomena that in code that slows us down and makes it hard for us to understand and work with the code. What do you guys think? Is friction a better word? Continuous learning and improvement. All right, yeah, we got some good reactions there. I think I like friction there. So, all right, I'm coming up to where we're actually going to talk about AI and what this thing can do. And are we smarter than AI? So, all that stuff that we just talked about, those are foundational for the next half of this presentation. So keep those things in mind. It's about understanding code. It's about being able to change it. It's about reducing cost and making it easy to work with, making the software easy to work with. So keep those things in mind, right? So here's I'm going to switch now to um, my IDE. So give me a second here. Excuse me. Actually, I'll just share my screen, my entire screen, so I can switch back and forth. This one. All right. So, and I'm gonna put this tab over here on my other screen so it doesn't mess with the infinite thing. Are you smarter? All right. Here's my Chat GPT session, and because I'm a cheap guy and I didn't want to pay the $20 for the upgrade, I used the default 3.5. So this is not 4. So my prompt to ChatGPT was create a Java program to play tic tac toe with a computer, and it gave me this code, and I copied that into my IDE, and then I said, okay, I mean, it looks pretty decent. Just a couple of things maybe, and we'll go and review this code. And it says, okay, I said create some unit tests for this code, and it came back with this stuff. That's the first version. And then I looked at its implementation, and the implementation actually uses a two-dimensional array, a two-dimensional character array. And I've done this exercise a few times, and I found that I actually like using a one-dimensional array. So I told ChatGPT generate the code using a one-dimensional array instead. So it did that, and it gave me a different version. And you'll see it's still pretty okay, except for all the statics. So it's not at all object oriented, right? And then I asked it to give me some unit tests for it. Okay. And then I asked, do these tests pass? He kind of waffled on this. Yeah, well, you go and run it, but they should run. But you need to verify whether they pass or not. And then I told him to find some code smells. So anyway, let's not get too caught up with that. I'm going to go into the IDE and show you that we can look at the code that it generated. So at this point, I want to see if we've got any brave souls who are willing to come up on stage and go on mic. June, do we have anybody who volunteered? I'd like to have at least 2 or 3 people who can kind of ensemble program with me or mob program with me. I will drive, and you guys can give your comments. And if not, that's fine. if you want to, June, if you could just read out loud some of the comments for me, so that I don't have to keep flipping back and forth between windows. You there?
Hi, sir. Let me check the comments if there are any volunteers.
Okay.
For a while. This is answer. I'm sorry.
Oh, sorry. I'm just calling June. Yeah,
uh, I'll try. Andrew, can you raise your hand so you can we can put you on stage and give you the mic if you would want.
I'm gonna go into presentation mode.
Yes.
Who do we have? Andrew?
Yes. Um,
Anybody else besides Andrew? Thank you, Andrew.
there you go, Andrew. Thank you for volunteering. Could we have another volunteer on stage? Or are you guys still asleep or what?
Let me see if I can. Okay, I've got my keyboard shortcuts. All right, I've got.
Come on, guys. This
Oh,
is a rare opportunity.
Andrew, can you give me kind of a sound bite? Just we'll see if we can hear you. Say hello, hello.
Andrew? Oops. Oh, okay. I think you're now able to speak.
Saying hello. Okay, I can't hear you yet.
Yeah, we can't hear you yet. He's saying hello, but he said he's saying hello, but we can't hear him.
No, I can't hear.
Okay.
All right. Well, um, try to figure that out, and if we get anybody else to volunteer, come on stage. That's fine. And um, if you want to just type your comments in
Yeah.
the and anybody can type your comment in
I'll
the
just read it out loud for you, sir.
yeah,
So,
yeah, yeah. So I'm gonna look at this first one that it created, tic tac toe 2D, for two-dimensional array as the implementation inside of the board. So all right,
so
slowly go through
Andrew
the board
said,
here.
sir, one abstraction per method.
One abstraction per method. Okay, and I get that, but are there any line numbers in particular that you want to call out? So let me start with this. Um, Describe your process for, like, let's say there's a program that you're just coming into. What's the first thing that you guys try to look at to start to understand what the code is doing? And wait for at least one response, and then I'll share what I do. What's the first thing you look for when you come into a program and say, I need to understand what this thing is doing?
Hubert said, sir, objective.
Objective. All right. Understand what the objective is. Okay.
And then Bernard said the entry point.
Okay. Cool. Yes, that's a good one. But with, let's say, for Java, you know that the entry point is going to be main, so that's kind of given.
Um,
Um,
Mar,
I, I'm yeah. Go ahead.
Mar said the first method being executed.
Okay. Again, main. So yeah, I mean that's a valid thing. Okay, I'm gonna share what I do.
Read me.
Um,
There's a
right.
there's an
Oh,
answer saying read me question mark.
read me. Okay. Another one. Another interesting answer. What
Jacob
I
said
do,
fundamentals.
function methods that will be created. Okay. So what I do is I look for tests and I start with the test. Being a TDD guy, that's what I do when I'm coding and when I'm first coming into some code is I look for tests. And if I don't find tests, I'm going to be like, oh crap, now I got to go read this code and understand it. Why is it that I look at the tests first? Not just when I'm developing it, but when I'm trying to understand it. Right. So the idea is that the tests, if they were well written tests, the test should tell a story, right? And this is not my idea actually. This is an idea that I got from Kent Beck. So I'm gonna exit here real quick, and I'm gonna show you a link where I got this idea from, and it's an old link. I'd like you guys to note this down. This is from Software Engineering Radio back in 2010, episode 167. The episode had Kent Beck as their guest, and he talks about the history of JUnit. But somewhere around the 34-minute mark, I think it's 34 minutes and 30 seconds, he starts talking about what constitutes good code and bad code, and what constitutes a good test and a bad test. And in here, at this point, he says, and I'm going to paraphrase, a test, the test should tell a story. There should be a beginning, there should be a middle, and there should be an end. There should be an arc to it, right? And if that test tells a story, then it that story really should be taking you on a journey of understanding. And that journey should be okay, this is where it starts, this is then it proceeds over here and everything. There should be a logical sequence to these tests, right? And when I read his book here, where's that book? It's on here. He talks about that as well. And if I go to the reading order, right, and cohesion order, he has this chapter called reading order. Let's say you're reading a file in code, and you're reading the whole file and get to the end. There's detail. Anyway, he says that the order that your code is in is important because that order should be from top to bottom. It should take the reader on kind of a journey of increasing their understanding. As they read, they should be able to go from top to bottom and form that same idea that you had when you were writing this code, right? So reading order is important. And one of the tidying up that he has is, make the code read like it make it read logically from top to bottom. I should be able to build out that story and not have to jump around like one of those old books where you get to the bottom of the page and it says like you choose your own adventure type book where if you want the character to do this, then go to this page, so you're jumping around from page to page, and it becomes very confusing sometimes. And it's fun as a kid, and this is different. But as a programmer, you don't want to be having to jump around the code. You want there to be a logical sequence to things, right? And that's why I think a lot of you said, I want to see what the entry point is, and that entry point should be the one of the first things you look at, right? And if you structure your test in this way, then and make it tell a story like Kent Beck was saying, then that's going to be a lot more friendly to the users of your code. The users being the readers of your code, because that's what the use of the code is most of the time. 70% people are going to be reading your code. So I'm looking at this test and I'm trying to see if it tells a story. And I'm actually going to run these tests and see. And this is the second thing I do is I try to run the test and make sure that they actually pass. And mind you, I haven't done anything to this code. This is the code as provided by ChatGPT. And look at what happens when I run it with coverage. Ba-bam. Couple of test failures on the the 1D version, another failure on the 2D version. So ChatGPT was smart enough to generate code, and it's smart enough to generate code for the unit test, but it wasn't smart enough to generate code that actually passed the unit test. It had to come back to me and say, "Well, I don't know. I can't run these tests. You go and verify that they run." And none of them actually pass. So let's see if we can figure out what this guy is actually doing. I'm going to go back. Hopefully, I can. All right, I can actually make this bigger, right? And so the first failing test, let's look at where the first failing test is. This one, test computer win. Now, does first of all, what can you guys say about this name? Is it a good name? Is it a bad name? Is there something that you're looking for in a test name that would tell you, this is something I need to change? It says test computer win. It's very generic, right? It's vague, very very vague description. It's not. It doesn't tell that story of what's actually happening in the code. One of the things I like to do, especially with JUnit, is I like to do this with add display name generation. Display name generation. Display name generator equals no, replace underscores that class. Right. And if I don't know how many of you guys have done this. Do you guys use this feature, display name generation? So look at the difference when I do this. And you see the report over here? It says test, test, test. I don't like those names because it's kind of redundant anyway. But if I change this thing to, let's see, test computer win. Let's analyze this. And then I'm going to rename this really quickly to who won in this game? Nobody won. Do you guys see anybody who won? Nobody won, right? Right? Nobody's going to win. So I'm going to say move to a game ends in draw. Game ends in draw. I think that's what this code is saying, or should be saying. That they have a scenario where they've got a bunch of moves and nobody actually won, and then I'm gonna assert that the thing. But anyway, the reason I use the underscore is because of this annotation. So if I run this again, you'll see that now the report will show game ends in draw, right? So it's not this camel case thing anymore. It actually replaces the underscore, and now it's more conversational. The report is reads more like a story, right? And so I go through and start analyzing what this stuff is, and I start mapping it to the coverage, right? So um, I say game ends in draw, and maybe I'll follow this execution and say, okay, check win, and see if I can tell the story of this code. So test 2D check win is, and you'll see that the coverage report for this is horrible as well. The red lines are not covered at all. So the code that it generated actually only has 33% method coverage and 18 and 21% method coverage. This 2D is 33 and 21. So coverage is not really good either. So for me, this is like the work of a poor coder, somebody who didn't really care about writing tests and making sure that things were covered, and definitely didn't do TDD on this, right? Because if TDD was done, then you'd have a lot higher percentage coverage. So it's vague. Um, so again, I'm gonna go back to the test and say the tidying up that I would do here to gain more understanding of what's going on in the code is I'd start renaming things. So I want you guys to think about the last time you refactored code. What was um, the refactoring that you did? Was it, I don't know, replace conditional with strategy, or was it more likely to be renamed? There's a reason why when you right click on refactor, what's the, what's the first thing that comes up? Rename. The reason why this is the first thing is because this is the refactoring that most people do, right? And yet a lot of people don't do this at all. They'll go and look at all these other things and say, yeah, I'm going to try to do this. So one of the things that I'd like you to start, if you're going to start adopting this mindset of I'm going to tidy up things and I'm going to make it so that my cost of maintaining this software is starting to go down or starting to get minimized, then the biggest thing you can do is start renaming things and making your code tell a story that takes people on a journey of understanding by starting from the top to the bottom of reading the test. Then they can start forming that story. They can piece together what you were thinking when you wrote this code, right? And here's another idea that I'd like to share with you. So what's a good framework for telling the story? And what I found is, without this framework, I used to be like thinking a lot about like, what's the first test that I should write. And there's this phenomenon. There's this thing I do on the side, and about every once in a while, I attend code retreat. I don't know if you guys are familiar with code retreat, but a code retreat is a whole day of practice of doing TDD and refactoring and unit testing. If you guys have never been to one of these, I strongly encourage you to try to attend one. And the next one is actually coming up next week, Friday and Saturday next week. Look for either an online event that you can attend, uh, or something that you can go to, like an on-site event, because these are really fun. And if you have a good facilitator, then you can learn a lot. But one of the things I've noticed in these sessions is that people have a hard time thinking up of, what are these tests that we should write. And one thing that really helped me um, get over that hump, right, that challenge, is this framework called zombies. And I strongly encourage you guys to go and read this blog article. It's from James Grenning, another one of the original signers of the Agile Manifesto. James Grenning wrote this article back in 2016. It says TDD guided by zombies. And zombies is an acronym. It's not these zombies, right? It's an acronym that means zero, one, and many. The main, the only numbers in computing, zero, one, and many. And then on another axis, you have boundary behaviors, interface definition, exercising exceptional behavior. And it's kind of a grid, right? Well, you start with zero case. What happens when there's nothing? Like, for example, for tic tac toe, what happens when nobody's moved yet? What are the things that we can assert about the behavior of this program? One is that nobody's won yet. right? And there should be nothing on the board. The board should be empty. And then when there's one, when you go to one, another thing you can assert is, okay, then X should be the first player to move all the time. Every time, maybe you have a rule that X always moves first. And then many, you can start following this story starting from zero case, one case, and many. And then when you're moving from zero to one, that's when you have a boundary condition. Like, for example, you have a stack. What happens when you move from empty to not empty, right? When does that happen? It's the first time you push something on the stack. So those are kind of the things like, and then the interface. How do I test, proper calls? Do I do should I expect an exception from this? And that's the E. So it's the intersection of all of these things, zero, one, and many on one axis, and boundary and interface and exceptions on the other, and trying to keep scenarios simple and your solutions simple. Then this is really a great framework for you to use when you're doing like TDD and things like that. And it's clear to me that this AI doesn't know how to do this yet, right? So this is another way that I don't think AI is there yet. And maybe, with more research and more training, then it can start getting to where it can actually follow this framework and give us good tests, right? But this is where my assertion is. AI can only do so much, and training a model can only get you so far. We still need to use our brains. We still need to apply our experience and all these little things that I don't know if we'll ever be able to create an artificial intelligence that understands these things and puts these things together. Maybe, but right now I don't think so. Not at this point in time yet. So we are coming up. Yeah, I was really hoping we'd have like a hour and a half for this, but I only got an hour. So you know, I touched on a very surface level thing. I want to do this exercise actually and carry out to the fullest because there's a lot of things that we can point to. Like another thing I noticed in this code that it generated is like what you guys said. Some of these methods are huge, and check win. I'm not really sure whether that's an appropriate way to interact with this class or this behavior. I'd rather not. I'd rather be able to say, okay, here are some moves, plot those out, and tell me who won, right? And again, this is where our thinking as human beings comes in, and really, fills the gap that's still there in the AI that we have so far. I want to leave a few minutes for some comments, some thoughts as we come to the end of this session. Again, I was really hoping that we could get into it a little bit more, but that's okay. I think if you guys try this yourselves and go read some of those articles that I pointed out and listen to Kent Beck and read his new book, and figure out, what are the things we can do to keep our code clean and easy to work with and easy to understand, then I think, AI can get us started, but we need to take it to the finish line so that we can really um, make use of our time and let AI do the heavy lifting, and we do the heavier thinking, right? I want to close there and see what you guys have to say. Any opinions? Any key takeaways? That's what I'd like to see. Anything that you sticks out in your mind in this discussion?
Sir, we actually have some questions posted
Sure.
during the entire. So that I think we only have three as of the moment. Then after that, we can proceed with the comments.
Mhm.
So right now, there's one very upvoted question: should tidying up code be included in a project's timeline from Ryan L?
Um, Now I'm gonna interpret this in a way that you know I'm gonna try to read between the lines, right? So what I'm kind of sensing is that you're not given explicit time to actually refactor your code. And my opinion there is I always put time in because tidying up is always part of writing the code. Um, and there's no separate time to do it for me. And it's like going back to one of the comments. You should be doing it all the time. Every small every small piece of code that you write, you want to step back a little bit and say, does this make a mess, or is this going to lead to a mess that I need to head off now, or can I keep going and still be able to work with this code without losing the understanding and the cohesion of the code itself and the ideas that are reflected in it. So I would say, you really should include that in your um, maybe estimates, but how you think of your work, it shouldn't be a separate thing. It should be part of the work that you're doing, and you should weave that in all the time. And you shouldn't ask for permission to tidy up your code because that's your job. It's your job to keep the code clean because it's going to come back to you, right? You're the one that's going to be affected most.
Yeah, I think there's a good follow up to that question, sir, from Louis Linag. He said, how do you approach tidying up code when you just engaged into a project wherein there's no practice of tidying up the code?
There's no practice. Well,
Yeah.
bitch about it. That's what we did. Like when we inherited a legacy application that we couldn't understand, we were bitching about it to each other. It's like, what the hell were these guys thinking? And after a while, it's like, look, those guys are gone. There's no point in us bitching about it because they can't hear us, and we don't know their addresses so that we can go egg their houses. So we have to own this, and since we own it now, we have to take care of it. Like it's like if you buy a house and the house is all dilapidated, it's it okay. It maybe it's the previous owner's fault, but now that you own the house, what are you gonna do? You guys just gonna bitch about it and suffer, or are you gonna start cleaning up and fixing up? Right? If you own the code, if you're responsible for it, you're also responsible for fixing it up. And so that's what I start doing is whenever we encounter difficulty in understanding, the first thing I told my team was, well, let's start renaming and extracting things so that we know when we come back to this code, we won't be scratching our heads again. So what the hell is this thing doing again? So that's how you start getting a handle on things. And when you really the first order of business is gaining that understanding. Because again, go back to what Kent Beck says. The biggest cost in software is just understanding what the heck the code is doing. So make that investment of knowing what the heck your code is doing, how it's organized, and get that model, that mental model built up in your head that really sticks with you and really resonates with the code that you're reading.
All right. Thank you, sir. Another question from Kim John. Could you
Mhm.
share some specific techniques or principles from his book that you find most valuable for ensuring clean and
Sure,
maintainable code in software
sure.
development projects?
Sure. The things that really stick out to me as being important is this reading order, right? When you read the code, it should be a logical sequence that it slowly builds up, that helps you build up that understanding. The cohesion order as well is again things that belong together should be close to each other. You shouldn't have to be something's declared here and then you have to go scroll or go to another file to see what the declaration looks like, right? Things that belong together and work together, have dependencies with each other, try to put them in close proximity. That's cohesion order, how things stick together, right? um, the other ones that are very, again, about readability, explaining variables, you name your variables so that they give you an idea of what the purpose is. Um, Chunk statements, this too. Like look for look for chunks of code because those chunks of code are actually candidates for extracting, right? We naturally put white space in our code, well, most of us, right, to delineate different responsibilities. And if you're trying to figure out what this long method is, look for those natural gaps in the code that people try to put in so that it helps them kind of um, draw lines in the sand. This is where this little responsibility ends and this one starts. So those are your cues for extracting things and breaking things down into smaller chunks. Um, Extract helper. And the first one too, guard clause, I think is a really important technique. There's this old way of thinking about multiple returns in your code, and the old advice was only have one return in every method. Every method should only have one return or one exit point, and that's not necessarily, a good practice. If you couple the idea of guard clauses with small methods, then it's very clear. This is what he says. If you have code like this, you have if condition in some code, if condition and not condition in some code, where you have a lot of nesting because of the many conditions. Try to introduce guard clauses so you're exiting right away once a condition is not met. So that's basically saying, well, you don't meet this criteria for executing all that code down there, so I'm going to kick you out. And then there's another criteria that you have to meet, so I'm going to kick you out. And so all these things guard you from having to execute that code underneath. And so that's a I guess fail fast, right? Kick you out right away, and then you can eliminate some of the nesting in the code and simplify the code actually. So the advice to not have multiple exit points doesn't really fly anymore if you're following this pattern. So these are just some, and then lastly, I'd say dead this one, dead code. If you had code that's commented out and you're using some kind of source control, then freaking delete the code. Because if you think that you need it, then you can always go back to the version before that had it and restore it, right? Because you have version control. Now, I don't know if you're developing without version control, but that's one way to live your life dangerously. But if you're
You're
sane,
saying
you want to use version control and delete anything that's fluff and cruft there. Remove it. You can always get it back. And usually, once it's deleted, you're not gonna need it anyway. It's like I want to say I have a closet full of like 50 jackets. I mean, I may be exaggerating. Maybe it's 45. But I'm looking at it and it's like, well, why do I need this many jackets? It's not that cold in Ohio. I need like maybe 4 jackets. Maybe when it's really really cold, when it's kind of cold, and when it's just kind of balmy. But anyway, it's like get rid of all that junk that you have in your code because you're not going to need it.
All right, thank you, sir. I think we're running out of time, so let's just get two more questions. So
Sure.
from Bernard, he's asking, how do you deal with code perfectionism? How do you know when to stop, given you have plenty of time to spare?
You need somebody to call it out, right? And one of my favorite quotes anymore. It used to be good. Uh, Perfection is the enemy of good, right? Or good enough. But then our guy named Arlo Belshi, who has this blog that I like about the naming process. He has a 7-step naming process. Arlo Belshi. I put that in the chat. Look it up. Arlo Belshi naming process. This is another good guideline to follow. But he says, yeah, perfect is the enemy of good enough, but good enough is also the enemy of doesn't suck so much. So I've come to be like, I used to be a perfectionist, but now I've gone swung the other way. It's like I need to get things done. So it has to be doesn't suck so much. right? As long as I can understand and not spend so much time scratching my head and figuring out, what's going on here, then that's good enough for me. And if you keep doing that, and if you just refactor a little bit, tidy up a little bit, you don't have to spend so much time making it perfect. Just a little bit. And it takes a while to get over that compulsion, right? I call it a compulsion because that's kind of what it is. It's you just have to learn to curb that enthusiasm to keep um, and the other thing too is don't care so much. I mean, that's probably a bad thing to say, but don't care about people saying that you're a bad programmer. Yeah, as long as they can understand what the heck you were thinking, then that's good enough, right? It doesn't have to be perfect. Get over it. You're gonna make mistakes. You're gonna screw up. So get over yourself and don't think that you have to be perfect. And that's what my wife told me. She reminds me every time that I'm not at all perfect. So take that with you.
Thank you, Sir Junilu. Okay, I think I'll just read out the last question.
Uh huh.
Um, this one, I intentionally put it last because it's more of a management perspective. So, how to get upper management buy-in for addressing frictions, as those are usually bumped out by business requirement priorities.
So um, one of the things I've done is don't talk to them directly. Track how much time you're spending trying to figure out things in your code, right? Things that are slowing you down. And if you put that, I did this at one of my clients that I was consulting with. We put on the board. They have a big information radiator, big board of what is it, waste or something like that, um, and it's big red letters. And then every day we track. Okay, this is how much time we spent dealing with bugs. This is how much time we got slowed down because of infrastructure concerns. This is how much time we got slowed down because the tests were crap. So all those things, and then you start kind of putting a value to that. Like if a developer costs, I don't know, let's just say $30 an no, $100 an hour, right? Just put it up there. Because managers understand money, so put it in terms of money. How much time you're spending, and translate that to pesos or dollars, right? This week we spent 3,000 pesos being slowed down. It cost us 3,000 pesos because of all this friction. Then we didn't refactor, and then now it's costing us 5,000. If you can show it that way, you can show them what it's costing you to not deal with the friction that you're experiencing. Then it'll start to sink into their heads. Okay, what are you guys gonna do about it? Because this is costing us a lot. So talk in their terms. Talk about money. Again, go back to what Martin Fowler said. Don't talk about moral stands because you already lost there. Talk about the economic impact of the friction that you're experiencing. That's how you get to their hearts, through their pockets.
All right. Thank you so much again, Sir Junito. I hope that answered your question, JC. And guys, I know nabitin kayo. So, as of this moment, actually, we're gonna try to recommend Sir Junili if you're still available around lunchtime, if they would
Uh-huh.
want to send a special extended session of yours for the workshop, for the hands-on workshop you wanted to do earlier. So, if it's okay with you, sir, we can
Yeah,
do a 15 with the, if the others would want to attend during their lunch break just to listen in and participate. So
yeah,
let's
yeah, absolutely.
create one after the next sessions, so we can
Okay.
do one over lunch. And so guys, just wait for the extended session prompt on our schedule. But once again, thank you so much, Sir Junilu, for joining us for this year's SoftCon. And guys, thank you so much for participating. And I hope you really enjoyed this session. Well, I can see you enjoyed because there are a lot of emojis showing on screen and a lot of people commenting earlier during your session. But thank you once again. And we hope to see you again later during lunch. And see you guys in the following sessions.
Thank you. Yeah, just let me know details and where I need to go. All right,
All right,
I'll
sir.
I'll hang around.